Good evening students and welcome back to my session. Today I don't want to teach you. Now you might be like, why don't you want to teach us? Because you didn't wish me a good luck, right? Because last class I told you not a good luck. You didn't simply ask me to take care of myself. You are very bad students. Last class I told you, right, that I'm suffering from cold. So, and it was the beginning. If you would have prayed, if you would have said that, ma'am, be good, take care of yourself, at least I would have taken care of myself. Now, since you didn't say anything, I didn't take care of myself, and now see, again I'm having a bad cold, right? So, it's all because of you people, and you're very bad, I must say. So today I'll teach you if and only if you will, say that, ma'am, be happy, be healthy. So every time I say be happy, healthy, wealthy, wise, right? So this time you should say the same thing to me also. Fine? Okay. So I wish that nothing should happen to me in the video. So before I sneeze, let me directly start with the video. And today we will be teaching, or we will be doing something related to the percentage S character. You remember, right, in the last class I was telling you the details about what is percentage S character and how could the percentage S character be useful to us in connecting all the dots in the chemical bonding, right? So today once again we will be moving on with the topic which is same as the topic that we were doing in the last class, which is the details about percentage S character. So as per I had already discussed in the last class that in today's class I'll try to discuss all the factors that we have been doing in our last classes with respect to percentage S character only. Okay. So once again if I write down the topic which is details about percentage S character. So what are the corresponding details that you need to know about the percentage S character? The very first thing that you have to remember is if the orbital has more percentage S, then what will happen? The orbital will be point number 1, bulky. Point number 2, smaller. Point number 3, bulky, smaller. Then you can say the bond will be a stronger bond, right? And also the central atom will be, so this was corresponding. Strength will be corresponding to the bond. Bulkiness and the smaller or the length of the orbital will be decided, or you can say the length will be decided in terms of either the orbital or the bond, whereas the central atom, if you talk about the central atom, it will be more electronegative. Right? So we discussed all these things in our last class. One another very important thing that I discussed in my last class, I remember that the lone pair would always love. So today we will be doing the details about this particular point, and now we will be correlating the same point not with the lone pair but with a more electronegative atom. Okay, so we'll do that, and that is known as Bend's rule. So we'll go into the detailed discussion. First let me write down this thing that the lone pair would always come to the orbital with more percentage S character. So if there is any particular orbital which has got a huge percentage S character, the lone pair would love to come to that particular orbital, right? Now, not only this thing, one another thing you have to remember that if all the orbitals are same, then the lone pair will first take up percentage S from other orbitals and also it will give away percentage P to the other orbitals. And I was in love with the statement. Okay, so this was all what we have discussed in my previous class today, and this was the point where I started catching cold, right? So that is a bad point, I should remember that. So now in today's class we will be doing the same things, but here instead of writing the lone pair, we need to figure out what will happen if you are taking a more electronegative atom. Okay, so if you have taken a more electronegative atom and you are asking that particular atom to occupy the orbital, will there be any changes in the orbital or what all will be there? So that is a topic that we have to discuss today. Okay, so please make sure that you know all the points that I have written on board, because this is the prerequisite for this particular session. Okay, now moving on to the discussion about electronegative atom. So let's try to discuss in details about electronegative atom. I am not sure how much I will be covering today, but I will make sure that I will go very slow so that you people can understand this particular point very nicely. Okay. Let us say we are doing the case of methane, right? So methane is CH4, carbon will be there in the center, will have 4 hybrid orbitals, where each hybrid orbital will be having 1 electron, and each hybrid orbital will have 25% S, 75% P. 25% S, 75% P. 25% S, 75% P. 25% S, 75% P. Am I right? Now let us say for the formation of a methane molecule, you basically want 1 hydrogen, like 4 hydrogens should be coming each with 1 electron. Now see, when hydrogen will come, it will say, "Yaar, hi carbon, I need to form a bond with you." So carbon will say, "I am ready to mingle up with you," right? So hydrogen can easily approach carbon, and now not only one but all 4 of them will approach. And don't you think that since there is no ego, like what is ego in chemistry? Ego in chemistry is something related to electronegativity. So since there is no ego from carbon side, there is no ego from hydrogen side, so this shared pair of electron will happily be there in between. Okay, so I'll tell you what kind of a bond will be formed between carbon and hydrogen. I think you people are smart enough to understand. Suppose a girl is getting married to a guy, okay? The girl is earning quite well, the guy is earning quite well. So I am telling you this thing to you people also, because maybe after 6 years you will get married, right? So see, if the girl is earning well and if the guy is also earning very well, right? And they are getting married. So now you do agree with me, right? That the girl should be like, boy should also be helping the girl in cooking, right? And the boy should be like, the girl should also be helping the guy in other household stuffs, right? So the two should be there in a mutual balanced relationship, right? So at no point of time the guy should say, "Why will I help you in kitchen," right? So there should not be anything. So there should not be any ego between the girl and the guy, because both of them are, you know, they are good people, right? So it's like, if this is a bond between carbon and a bond between hydrogen, so both of them are earning well, both of them are happily enjoying their married life. So their shared pair of electron will be totally in the center. Carbon will not say, I want to have a share of electrons towards myself. And neither the hydrogen says that, I want to keep all the money with me. No. So the very nice guy, very nice girl are there, right? So the bond should be formed in such a way that the pair of electrons should be exactly between carbon and hydrogen. Both of them should be earning good also. Both of them should be helping each other in every household activity. So this thing you will be using after 6 to 7 years in your life, right? Now, I have seen people who are not like methane, okay? But now let me tell you another situation. Suppose we need to do the formation of CH3F. Now, this is what we need to consider. So, once again, what is central atom? Central atom is carbon. So, let's do slowly and slowly. See carefully. 1s2, 2s2, 2p2, right? 1s is closer to the nucleus, not at all good, not at all required. Now we will be left with 2s2, 2p2, okay? Carbon has to form how many sigma bonds? Carbon has to form a total of 4 sigma bonds. So carbon needs 4 unpaired electrons. So one of the electron will get excited. See, I am following exactly the same principle. So when one of the electron will be excited to the 2p orbital, then all 4 of them will merge with each other. And when all 4 of them will merge with each other, 4 new orbitals will be formed, and these 4 new orbitals will be known as hybrid orbitals, right? Now, these hybrid orbitals, as per was the case of carbon. See, listen carefully. These hybrid orbitals still belong to carbon only. They have got nothing to do with the incoming atom. They have got nothing to do with hydrogen. They have got nothing to do with fluorine. Right now, only and only carbon atom was hybridized. So the orbitals that will be formed will also be exactly same as they were there in the previous case. So each orbital will look exactly similar to the other orbital. Each orbital will have a total of 25% S, 75% P. 25% S, 75% P. 25% S, 75% P. 25% S, 75% P, right? So each orbital is exactly same. Each orbital is having 1 electron, right? Okay. Now see, for example, let us consider one another bad example. So carbon was the father, he had 4 sons, each son was very nice, right? And he is trying to get all his 4 sons get married, so he is trying to get them married to some girls, okay? So 4 girls were there, out of which 3 girls were hydrogen. Each hydrogen is saying, I am single but ready to mingle. But one girl was fluorine. She was also like, I am single but ready to mingle. So what happened? When these 3 hydrogens came to the 3 orbitals, they got happily married. Happily married, happily married, happily married. Okay? And when fluorine came to the hybrid orbital of carbon, then also the marriage was happy. I mean, everything was good in the wedding. Happily married. Okay? But now consider the situation. Suppose these 3 girls, so suppose these 3 girls are there, they are not earning anything. Okay? So let's say, oh my God, so sorry. So see, what I am trying to say, suppose the 3 girls, these 3 girls are there, they are housewives. Okay, but this lady, this fluorine, she is a working woman. Okay, so she is a working woman, whereas these three girls, they are housewives. Now what will happen? The carbon which was forming, the orbital of the carbon which was forming a bond with hydrogen, there was no ego between carbon and hydrogen. Okay, no ego was there at all. Similarly, between this carbon and hydrogen, no ego at all. This carbon and hydrogen, no ego at all. Why? Because hydrogen is not electronegative. Hydrogen was not egoistic. Hydrogen was like, I am a good girl types, right? So, the three bonds which will be formed between carbon and hydrogen will be having the shared pair of electrons there in the center, there in the center, there in the center. That means hydrogens are happy getting married to carbon, and they are very nicely having their, they are spending their married life very nicely, very easily. But now let us consider the case of fluorine. Now this awesome girl, I should say, this was a working woman. I mean, no offense to anyone, okay, it's just an example. So this was a working woman, and she was very, very, very egoistic. So when carbon came home and then he was like, can you get me a glass of water? So this girl will be, I also came just a minute back, can't you get me a glass of water? And then there was a huge fight in the house, right? Because she was egoistic, that why should I do anything? Why should I share the pair of electrons equally with you? See, for a happy married life, the pair of electrons should be there in the center, right? The way it is there in this, the way it is there in this, the way it is there in this. Similarly, these two electrons, this pair of electrons should also have been there in the center. But fluorine is so damn bad. She's so electronegative that it wants to keep the shared pair of electrons towards itself. Okay, so there is a problem with the ego of fluorine. There is a problem with electronegativity of fluorine, right? So you remember in the case of a lone pair, when everything was same, in case of methane, each orbital was having 1 electron, everything was happy, 25%, 25%, 25%, 25%, right? But then in last class we discussed the structure of ammonia also, right? I said that instead of a pair of electron called as a bond pair, there was one lone pair. And when the lone pair came, lone pair wanted to take up all the percentage S towards itself. So lone pair simply announced, I will not come to any normal orbital. I will come and first suck all the percentage S towards me, and then only I'll enter into the orbital, right? So the lone pair was very clear, no? I had written one sentence that the lone pair will always occupy the orbital which has more percentage S character, right? Or the other way I had written, lone pair wants to come to that orbital which has more percentage S, or if all the orbitals are having same percentage of S, then the lone pair would first suck all the percentage S, and then only it will go and have a seat in that particular orbital, right? However, an equally opposite effect is working in the case of an electronegative atom. Why? See here, this shared pair of electron, if this shared pair of electron was formed by or was lying in an orbital with 25% S and 75% P, that means this shared pair of electrons should have been behaving like the CH bonds, and the shared pair of electrons should have been there in the center, right? But then fluorine is egoistic. She says, how the hell you can keep the shared pair of electron with yourself? I need to have a hold of the shared pair of electron. Now, how can fluorine have the hold of shared pair of electron? So this is possible if and only if percentage S in this orbital is less, because the percentage S